Welcome back to the Applied Deep Learning course. In this lecture, I would like to give you a short introduction into deep learning, give you some examples of successful deep learning projects to show you what is possible nowadays with this technology. I hope that some of these examples will inspire you for your own projects to do something that is interesting and useful for you. I would like to start with a simple question. Is this email spam? Congratulations, you've won 650,000 euro in the monthly Euro Million Google promo lottery. Please consult this email address for claiming your winnings with the following information about your full name, address, and obviously your credit card number, which is very important here. I think every one of us has seen such spam emails before, and it's kind of obvious it's spam. However, let's have a look at this example here. Greetings. I'm Miss Margaret Komai Nung, Deputy Chairman, Managing Director and Executive Director of Chonghing Bank Limited. I write briefly to seek your collaboration in a multi-million transaction with good return for us on participation. Reply for details. Regards, Margaret Ko Leung. Is it spam or not? Probably. But if you ask a computer to say whether this email is spam or not, it's already much harder. When you think about it, the previous email, it was very easy to see. Someone is asking you for your credit card number, you've won the lottery, it's some Euro millions or something. It's a clear scheme. You can, for example, define a set of keywords, and if they appear in an email, it's high likely that this is spam. In this email, it's actually already much harder. You have to understand the context here, and it could be a legitimate email if you're working for a bank. Who says that you're not receiving exactly such emails every day? So you have to understand the context to make good decisions. Another example. What do you see here? A cat. I hope you're all seeing a cat. But when you ask the computer to tell you what that picture depicts, how does it know? I mean, well, it could try to identify something like the ears and the whiskers and the eyes, and with that information could say that it's a cat. But it's not always that easy, and especially when you think about how will a computer know what ears and eyes are, right? It's quite difficult. I also love this picture where people collected images where animals looked like food or other stuff. And this is a great example of bagels and muffins, how they can look alike. And of course, this is more of a comical version of this. But again, how would a computer know that these are eyes or ears or a nose and not just some blueberries? Of course, if the computer understood that there is some icing and some sugar on it, then that would be a strong indicator that it's not a dog, because it's unlikely that you find sugar on a dog. When you would like to solve such problems and you think about it and you want to build a rule-based system with classical programming where you build if-else conditions and loops, you will quite quickly reach the limits in many domains. For example, you can build some algorithm that extracts information from that image, but at one point it will become extremely difficult to understand that program, and machine learning can be a viable alternative to imperative programming when we're hitting that wall. So what we're doing is that instead of defining the rules what to do, we're using data to answer questions. This is not new. Statistics, etc. have been around for a long time to exactly do this. So machine learning is, in a nutshell, using data to answer questions. And these two parts correlate to the training of using data to extract knowledge to answer meaningful questions, to perform inference on new data. And I have to say, when I learned about this definition of machine learning, I thought it's great. It's definitely the best definition that I've ever come across. Using data to answer questions. I already used the words artificial intelligence, machine learning, deep learning, etc., but I haven't clearly defined it. So let me give you some information here. Artificial intelligence is considered to be the broad overall field that covers everything in this domain. I personally think it's more of a marketing term because it's very challenging to define what artificial intelligence is, as it ultimately boils down to the question, what is intelligence? And also for intelligence, it's challenging to say what it is. Probably something that humans are better with than machines right now. So let's leave that marketing area and go into something that we can grasp a little bit better, which is machine learning. Machine learning is, for example, linear regression. It's exactly what I said before, using data to answer questions. So you have some points and you would like to understand the correlation of, say, two different factors, how the size of a person and its weight correlate to each other. Then you can use linear regression to understand how they relate to each other. And within machine learning, there is one section that is extremely important nowadays, which is representation learning. Representation learning means that instead of using all of the data to answer our questions, we're trying to extract useful information and put that into a model, into a suitable internal representation that can then be used to answer these questions. And neural networks that are inspired by how the brain works are a great example for representation learning. They're much smaller than the original data set and try to extract the necessary information for solving some problems. And finally, there is this small circle of deep learning where we use representation learning, more specifically neural networks, in a very specific way with a lot of depth, if you want, with lots of layers, a lot of parameters, and that would qualify as deep learning. I just want to say that this kind of border is a bit blurry. There is no clear cut where you say, if you use 4 layers, it's not deep learning. So people can argue about this. It's, again, I would say deep learning, also certainly a bit of a hyped term, but generally when you have large neural networks, it falls and qualifies into this area of deep learning. So when you try to solve a challenge, for example, you want to understand if this is a car, a person, or an animal, I already said it can be useful to have an understanding of what's going on there. Ideally, high-level understanding. We want to have high-level features such as eyes, a nose, whiskers, ears, etc. that help us. And deep learning models can achieve exactly that. What they do is that they have a hierarchy of low level to high level concepts. So you will input information and the first couple of layers will produce low level features or learn to extract low level features such as colors, edges, etc. And then on the higher layers, as you go through this network, it will learn more useful features like corners, contours, etc. And at the end, before you go into the final layers of your network, it will be very specific. So the neural network will activate, or that neuron more particularly will activate highly when it sees, for example, eyes or other object parts that are relevant for a certain task. And given that we're learning this representation automatically from our data, is the reason why deep learning is so enormously powerful. People have tried for many years to build such high-level features, but they were only able to kind of learn to extract medium to low-level features that are very general and generic and useful, obviously, for many things. But it was always difficult to kind of get to these high-level features that are task-specific. And they've used machine learning for that before, but the really cool thing is with deep learning that you basically try to do all of that end to end. So you learn low-level features, medium-level features, and high-level features all by yourself from the data. So how can a machine actually learn all of that? Is it magic, or what does it do to do this? We are talking about representation learning, and for representation learning you need a model. A model is the set of rules, kind of your calculator, that contains all of the information on how the data should be processed. It contains some parameters that tell you how to do it, and these parameters you will have to learn for your model. The second part is your loss function, and the loss function will tell you how good you're doing right now. You input a piece of information, and then you can compute the loss, kind of how good it's doing or not. And ideally, of course, we want to have a low loss, which means that you're doing the job well. And the last part, the third, is an optimization function, something that allows you to improve. So you have your model, you send some data through, and you evaluate it through your loss. And then the optimization function would tell you what you have to change in your model to improve so that the next time you see that piece of data or a similar piece of information, it will perform better. It will have a lower loss function. Now let's have a look at some examples about successful deep learning projects where we've achieved remarkable results in the last couple of years. The first one would be image classification. So you take a small image and you say, what is the main object that is present in that image? It can be an airplane, a car, a bird, etc. So here you have around 10 classes, and this is an extremely popular task because deep learning models work extraordinarily well here, and it's a great playground to experiment and learn about the field, because at the end you can just look at the output and see, okay, this is in fact a car, no, this is a frog and not a car. Image classification can seem like an arbitrary task, but there are many great applications for this already, and this is an example where image classification can be used to classify skin lesions, so alterations of your skin that can be harmful or benign. And image classifiers have shown, or deep learning models have shown, that they can actually work on this and can help to kind of classify this. And if you think about it, if that technology works really well, it could help millions of people around the world if they can just use their smartphone and take a picture of their skin alteration, and the thing can tell them, well, this is harmless, or please go and see a doctor, this could potentially be harmful. Object detection is another example where deep learning has brought significant advances. I personally used object detection in the field of music. As you can see on the left, this is a piece of handwritten piece of music, and I used object detection to find all notes and stems and other objects that are in my page before I go into the next challenge, which is then understanding the music itself, which is also very challenging. Or as you can see on the right, cars, like to just find and see how many cars are passing through a tunnel, for example. Voice recognition is another example where machine learning models have achieved extraordinary results. You can talk to your phone, and there is a very high chance that it will internally use a machine learning model to process that, and nowadays they work already very well and to kind of write what you've just said. I want to give this small example here, which I think is a great demo for voice recognition and natural conversion from the Google AI team.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a woman's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
I think that is an amazing piece to hear if you consider the following. Only one of those two voices that you've just heard was real. The other one was a computer that was given the task of booking a woman's haircut, and it kind of called the hairdresser, and then it started a conversation that sounded really natural to me, at least, where it kind of produced some information. So it listened, it processed what it heard, it reasoned about the information that was being spoken, and then it produced an answer that was synthesized again into something that sounded very human-like, and that is something that personally I think is an amazing result to show that machines might be able to solve such tasks for us in the future in a really good way. Obviously, every technology can also have some downsides, and I would like to show you another clip of one of my favorite comedians, John Oliver, about robocalls.
Well, I'm calling about an online request you once made about health insurance coverage.
Okay.
I work with all major companies and compare...
Hey, are you a robot?
What? No, I am a real person. Maybe we have a bad connection. I'm sorry about that.
Will you tell me you're not a robot? Just say I'm not a robot, please.
I am a real person.
I mean, I believe you, but will you just say I'm not a robot? It'll make me feel better to hear you say it.
There is a live person here.
If you could say the words, I'm not a robot, it would really mean a lot to me.
I am a real person. Can you hear me okay?
Right, but will you say I'm not a robot?
This example is obviously a good example of how the technology can be abused and how it has gone wrong in this example. In the US, I think this is a real issue, that people can be called up by these robots that are trying to sell something, and it's kind of a plague, and I think they want to stop it as soon as possible. But it's still funny to listen to this robot fail in this case. Another example that I personally am really interested in and that I think is super exciting is everything that has to do with music. In this example, there is a system called Deep Bach, and what it does is it performs harmonization in the style of Bach, meaning that there is a main line of the melody, and the computer was trained on Bach's compositions to complete that melody with the remaining voices. So the middle and the low voices for that melody. Let's listen to an example. right? It sounded great. And when they asked people which one they liked more, the original composition or what the computer wrote, some people even said that they preferred what the machine composed over what Bach originally wrote. You can also create entirely new music with some generative approaches, and this is an example that I've played around, and I encourage you to visit this link and try it out for yourself. It's super fun how you can make some music. Might not win an Emmy, but I think it's still a decent piece of music that I was able to create by just using 8 keys on my keyboard without any proper knowledge about what I was actually doing here, because the computer used my input to create something that sounds okay-ish, I would say. This is one of the more recent examples that I think is also very impressive. This is a model that is capable of creating images from a text prompt. In this example, an illustration of a baby fox in a suit playing guitar was the input that was given to the neural network, and it generates these images. I mean, look at it, that's fantastic. I think it's super exciting that the machine understood what we want here just from understanding the text input here, like an illustration. It's not a photorealistic impression, but like a cartoon, a baby fox, whatever that means. For the machine, probably that the head should be much bigger than the body. A suit, so it created some ties and some colors here. I think it's great. I really like this project. Also, I can recommend to head over to the website, try it out and see what's behind the technology there. Last year, I've been asked by some students if they couldn't create an AI that actually programs for them and solves all of these problems for them so they don't have to program anymore. And I was joking and said, I don't think that's possible. And time has proven me wrong. There is already now a machine learning model that is capable of producing Python code or other machine code, like computer code that actually runs. And there is an extremely nice demo here where they created the documentation, a doc string of what they want to have. And then the computer tried to build a program that can actually to write the source code that solves this task. If you take a look under the hood, it's a text model, so it kind of tries to process some input text and create some output source code, and it was trained on a huge set of source code, so it saw a lot of that in the past and therefore is capable of doing it. I still believe it's very impressive that there are approaches and machine learning models that can do such advanced things as producing legitimate, correct source code for programmers. The last example I want to give you is from the gaming world, and it's about the game StarCraft 2. Let's have a look at this. What you can see in the image is a DeepMind computer model that is playing StarCraft 2. StarCraft 2 is a real-time strategy game where you have to produce units, fight against your opponent, and it's considered a very complicated game because there are so many options what you could do at each point in time. And they've built a system that reads in what you see on the left, so it sees the image, it these kind of raw observations, it also gets some additional information and then feeds that information into the neural network, which then is asked what should be the next step. So should I build a new unit? Should I move units around, etc.? And what you see here are the parts that I mentioned before in this illustration. So at the right, so the model are these neural network activations, but on the top right you see the loss function here called outcome prediction. And what it's doing is it tries at each time step to say, will I win this game or not? And will take actions that maximize the chance of it to win. In this case, it played against Mana, who's a world-class champion in this game. And the computer was considerably better than that human, even though it was kind of throttled down to not do more clicks than, I don't know, 5 per second or something, which is kind of comparable to what humans can do. And the only game that Mana was able to, in which Mana was able to beat Alpha Star was where he kind of discovered a bug and then lured the computer up and down, and in the meantime defeated the opponent. And what made Alpha Star what's so interesting about Alpha Star is also that it was trained kind of from zero on this game, or I mean, it had some previous training on existing machine, but more specifically, it played against itself. And it played so much against itself as if it was 200 years old and did nothing but playing StarCraft 2 the whole time. So it learned a lot of strategies, it learned how to play the game by just playing against itself over and over and over again. In summary, machine learning can be an alternative to imperative programming, especially when it's very hard and difficult to formulate the solution of your problem in a way of saying if then else. If this becomes too complicated, machine learning can help you with that potentially. It's when instead of giving instructions, you use data to answer your questions. And I hope that I was able to convince you that with deep learning you can do some pretty cool stuff. And I hope that you're as excited about deep learning as I am. And I see you next week.